Hello, boys and girls. Welcome to Mrs. Bandu's Math Movies. This is, for my algebra class, Lesson 4-1, Inequalities and Their Graphs. Our objectives are to identify solutions of inequalities and graph and write inequalities. Okay, so our vocabulary term is a solution of an inequality. A solution of an inequality is any number that makes an inequality true. Okay. And we'll find in solutions of inequalities that oftentimes there are an infinite number of solutions, but they begin at a specific value and then are either greater than or equal to that value, less than or equal to that value, greater than or less than that value. So it is, although the thought process is very similar to working with equations, inequalities are a little bit unique in that they have actually sets of numbers for their answers. Okay, identifying solutions by evaluating. Is each number a solution of 3 plus 2x is less than 8? Basically, you just substitute in. Here, our first value is -2. So when I substitute in, I get 3 plus 2 times -2 is less than 8. Or 3 minus, whoops, why did I write 6? Don't know. 3 minus 4 is less than 8, and 3 minus 4 is -1. -1 is less than 8 is a true statement, so -2 is, in fact, a solution. When we try substituting in 3 in part B, we get 3 plus 2 times 3 is less than 8. 2 times 3 is 6. 3 plus 6 is 9. 9 is less than 8 is a false statement, so then that makes 3 not a solution. Again, when we substituted in -2, it was a solution, or because it made the inequality true. Okay, so it's just pretty straightforward. It makes it true or not. If it makes it true, it's a solution. If it does not, then it is not a solution. Okay, and then graphing. We want to graph D is less than 3. The solutions of D less than 3 are all the points to the left of 3. So I go to a number line, I find 3, and I put an open circle there because I do not want to include the number 3 as part of my answer, but just numbers that reach 3, so to speak. And I will shade the number line to the left of that. Okay, so open dot at 3, shade to the left, D is less than 3. Next one, graph -3 is greater than or equal to G. Okay, the solutions of -3 is greater than or equal to G are -3 and all points to the left of -3. Okay, now when I see inequalities written like this, I like to rewrite them to have the variable on the left. So you can do that as long as you keep your inequality. If the point is toward the variable, keep it toward the variable. If it's toward the number, keep it toward the number. To me, this is a little more logical. For whatever reason, that's the way my brain works. It also, if you have the variable coming first, basically tells you this points into the direction that you should be shading the number line. Okay? So what I'll do here is, this time -3 is included as a value because of the negative sign in there. So I'll put in a solid dot, and I'm going to shade to the left again. So there's my graph for G. G is less than or equal to -3, or -3 is greater than or equal to G. And finally, write an inequality from a graph. We want to write an inequality for each graph. Okay, so we see this here, and we see that numbers less than 2 are graphed. So my inequality is x is less than 2. In part B, numbers less than or equal to -3 are graphed. So my solution is x is less than or equal to, again, the solid dot indicates the equal in there, less than or equal to -3. Okay, really that's it for examples in this section. You do have, turn the page, and you will see that there are several quick checks, so please have those completed by the next time we meet in class. I look forward to seeing you then. Goodbye.